Okay, and then from example 2, we are doing problems from section 8.4 and from section 8.5, where we multiply, divide, and add and subtract rational expressions. So, in example A, know that we are just doing fraction division, which is going to involve copy, dot, flip. So we copy our first fraction, 2x cubed minus 12x squared over x squared minus 4x minus 12. We change it to multiplication and we flip our second fraction, x squared plus 9x plus 18 over 8x cubed plus 24x squared. From here, we are just going to factor everything because we cannot cancel until, oh boy, we have things factored. So our numerator on the left, we can take out a GCF of 2x squared, and we're left with x minus 6. Our numerator on the right, we can take out, we don't have a GCF, but we can set up our parentheses. We're looking for two numbers that multiply to 18, add to 9, that'll be 6 and 3. Our signs are the same, they are both positive. Denominator on the left, we have two numbers that are going to multiply to 12 and subtract to 4. That's 6 and 2. Our signs are different. Our bigger number is negative. And our denominator on the right, this one we're going to have one more GCF. It'll be an 8x squared, and we're left with x plus 3. And then from here, we see what all we are able to cancel. So, looks like we've got an x plus 3 over x plus 3 that'll disappear. And our x minus 6's, nope, don't quite, oh, there we go, yep. So we've got an x minus 6 over x minus 6, sorry. I was trying to cancel it with this guy, which would not make sense. So our x minus 6's disappear. And then we've got 2 and an 8, so those can become a 1 and a 4. And then x squared and x squared, those are both gone. All that's left in our numerator is x plus 6. All that's left in our denominator is 4x plus 2. Final answer. Now in example B, when we are subtracting, we need to think about our common denominator. So first thing I would do is change this to a plus -5 because that's going to help us later on, and we'll talk about why. But we need to be able to get our common denominator, so we start by factoring. So our denominator on the left, x minus 4x plus 3. And our denominator on the right is 3 times x minus 4. So our LCD in this situation, well, our x minus 4 is the same between them. And then we also just need to include the 3 and the x plus 3. So we think about what pieces each fraction is missing. Our denominator on the left is missing the 3. So we multiply top and bottom by 3. And then our denominator on the right is missing the x plus 3. So if I multiply it on the bottom, I also need to do it to the top. So our fraction on the left, the numerator is going to be, we distribute to get 9x plus 3. Fraction on the right, remember we're really distributing a -5. So we have minus 5x minus 15 all over our LCD, which I'm just going to move that, call it good. And then on our numerator, we can combine like terms. 9x minus 5x, we've got a 4x, 3 minus 15, -12, all over 3 times x minus 4, x plus 3. And it kind of looks like we might be able to get something else to cancel. So if we're trying to figure that out, let's factor our numerator. So that's going to be 4 times x minus 3 over 3 times x minus 4x plus 3. So super close to canceling, but it will not actually cancel with the x plus 3 in our denominator. So we have to stop here. Alrighty, and then the last problem that we have from chapter 8 would be this example 3, which would be from section 8.6, where we are solving rational equations. Well, we solve rational equations by either cross-multiplying if we have one fraction equaling another, or in this case, where we're going to have to multiply everything by the LCD. Well, in order to do that, we want to know what that least common denominator would be. So if we've got our x squared minus 1, we want to call that x plus 1, x minus 1. And then we can more easily see that that is, in fact, our least common denominator. So we want to take that and multiply it times each individual piece. So we'll have 5x over x minus 1 times our LCD. And I'd stick it over 1 so we can multiply fractions. Minus 2 over 1, or since we don't even need either of these to be fractions, just minus 2 times. And then I'm going to go back to calling that x squared minus 1, since we're going to end up having to distribute here in a little bit. That equals 14 over our x squared minus 1 times our x squared minus 1, or our x plus 1, x minus 1. Same thing. Now, a lot of things will cancel, which is good. They're supposed to. So we have our x minus 1s that'll cancel. In our numerator for our first piece, and really we don't even need our denominator, it's just a bunch of 1s, we are going to go ahead and distribute that. So we'll call it 5x squared plus 5x. Second term, we will distribute that negative 2. So we have minus 2x squared plus 2, equaling just a plain old 14, because our entire LCD cancels. From here, we are going to go ahead and solve our quadratic equation, which we typically want to try to get 0 on one side. So we've got 5x squared minus 2x squared. We've got a 3x squared, and then plus 5x, and then we'll go ahead and subtract that 12 from both sides. So we have, minus 14 from both sides, so we get a negative 12. Equals 0. And then we'll see if this guy can factor. So we're going to multiply and see, because we would have to divide inside. 3 times 12, we are getting 36. Numbers that multiply to 36 and subtract to 5, that would be 9 and 4. So I set up my parentheses. I have x plus 9x minus 4. And we want to divide inside by 3. So we have to slide it on the 4, but 9 over 3 is going to reduce. So we have x plus 3 times 3x minus 4 equals 0. We set those both equal to 0 and solve from there. We get a negative 3 and a positive 4/3. So sorry about that from the answer key that's on eBackpack. I think that at somewhere along the line I got a 13 right there, so I was not able to factor mine. But we do actually apparently get factorable, factorable quadratic, which is great. Now, before we call it a day, we want to take a look back at our original equation, make sure our answers are not extraneous. Well, if we think about the only numbers we could not plug in at the very beginning, we couldn't plug in a positive 1, right? Because plugging in positive 1 would make that denominator equal to 0, and this one. We also could not plug in a negative 1 because of how it factors. So since neither of our solutions give us a 0 in our denominator, neither of them are extraneous.